Hello, everyone. I'm going to go through how to read a position graph, kind of get started with this motion stuff. First off, though, I want to talk about what a graph does, so then we can move on to what a position graph is. Generally speaking, graphs represent data visually, so hopefully it makes it easier to understand the data and kind of pick up on the trends more importantly. Okay? Because it's looking at the relationship between two variables. Okay, really what that means is if you change one, what happens to the other one, right? And so on a position graph, it's looking at how your y variable, the position, changed over your x variable, okay, your independent and dependent variables, obviously, how your position changes with time. Okay, so from any given position graph, we can find two things. The first thing is you can find the position, obviously, at any given time, okay? And here I am going to talk about position as the variable x. Okay. The other thing, which is often more important, is we can find our change in position. Okay. Our change in position can be from beginning to end. Okay. The other thing we can find is change in position per time. Okay. Which by now we know is velocity. Okay. And on a graph, our change in our dependent variable or our y variable, our position, over our change in independent variable or x variable is our slope. Okay. And so as our position changes one way or the other over a given time, we can find our velocity using that position graph. Okay. And so when you are reading a position graph, there's three steps to it really. Step number one here is where does the object start, right? And so really we've got three options as to where it's starting. It can start at a positive location, at 0, or at a negative location, okay? And now you might ask, what is positive, negative, and 0? It depends on your frame of reference. In any given situation, it might be given to you, or you can choose it. If it is not specified, I tend to start my objects at time or position 0, and so we would start there, okay? Then we have what direction does it move? Again, we have three options here. We can say it's moving forward. Okay. We can say it's moving backward. Or we can say it's not moving. Okay. And here, forward would be a positive slope. Okay. Forward is a positive slope. Okay. So we can mark this line 1 here. That'd be line 1. We could be moving backward. We could be moving backward here at line 2. Or if it's not moving, okay, if it's not moving, our position is not changing, and on any graph, if anything's constant, it's going to be a horizontal line. I went above the line just so you could see it, but really it should be completely horizontal. Okay. Then lastly, where it gets a little more complicated is how does it move, okay? Really, we're looking at two things. Is it constant velocity? If it's constant velocity, it means it's changing position at a constant rate, which means you've got a straight line. So in all three of these lines I've drawn here, it's moving forward constantly, it's moving backward constantly, or it's not moving constantly, which also would be considered constant velocity. Okay. The other thing you can be doing is changing velocity or accelerating. Okay. But right now we're going to stick to changing velocity. And so if your velocity is changing, what that means is you are changing the rate at which you are changing the position. So you're going to have a curved line. Okay. So let's take a look at a couple examples here. So here we have a person wants to get their mail. So they walk outside of their house to their mailbox, get the mail, return it to their favorite chair inside. Here we have the position graph, okay? We start at position 0, and I'm going to call that position 0 right here, okay? That is position 0. Because at time 0, we have opened the door, we are going out to get our mail, okay? We move forward. How do we know we move forward? The slope of this line is positive, okay? So I start at 0, I move to about 3 meters, we're going to call it here, okay? That's forward 3 meters, okay? And so at time 2, position 2, Okay, here we are, we get our mail. We then turn back around, okay? I know I turn around because my slope is now negative. My position is getting smaller with time, okay? So there's a negative velocity. I move backward and I end up behind where I started, right? So I go in, go outside, get the mail, come back in, shut that door probably, and then I end somewhere in my favorite chair here at time 4. Okay. I move forward because it's a positive slope. Negative slope, I move backwards. And then here I've found my chair or whatever it is, and I stay still. Okay. Positive velocity, negative velocity, zero velocity because I'm not moving. The entire time it is constant. Why is it constant? Again, all of those are straight lines. So each 3 segments individually are constant. It changes at 2 seconds and at 4 seconds. But right now we're not going to deal with acceleration, and so it changes more or less instantaneously. In real life, there being a slight curve, but right now we're keeping it simple. Okay, we're going to look at one more example on this one. Okay, a soccer player starts at the goal line. Okay, we're going to say we start, let's get a different color marker here so we can see it. Black one, okay. We start at the goal line here. They run towards the halfway line where they stop momentarily here and return to the goal line. Their motion is graphed below. Now, this is a curved line, okay? So it is no longer constant, it is changing, okay? If we start here, we start at rest. So we know we start out slowly. If any of you have ever ran, you obviously don't start out at your max speed. So you start running slowly, and then you get faster. Or you may speed up, right? We can see this in the graph because, let's get, okay, here, the graph, the slope of the line is not very steep, okay? And so because it's close to being flat, it's got a slow velocity, okay? So we've got small slope, which means a small velocity. We then see that the graph gets steeper, or what we can say is the change in position per time increases, right? In this period of time, we've not moved very far, but from, let's say, here to here, in about the same amount of time, we've moved much farther, right? So greater slope means I have increased my velocity, and you've got a greater velocity, okay? As you get towards that halfway line, you want to stop and turn around. So you're going to slow down, okay? We can see that here with, what color are we going to use today? Blue. Here, as we turn around, right? Because here we've got positive velocity, here we've got negative velocity. Right in between those two, we're going to have zero velocity. So from here to here, this slope is decreasing again, okay? And so we're slowing down here. Our velocity is decreasing. And then we momentarily stop, okay? If you run one direction and go the other direction, in between there, you're going to stop. And then as they sprint through back to the goal line, they're going to have a negative velocity like we said, okay? But our slope is getting more negative, okay? So if you've got a more negative slope, your velocity is actually decreasing. Okay? Because if you start out, like we said here, at 0 meters per second and end up going, let's say, negative 4 meters per second, your velocity has gotten smaller. It has decreased. Okay, let me fix that 0. That's not a 0. Back here. 0 meters per second. Okay. Now, if you looked at being stopped and where you're running at the end, obviously you were moving